Hello and welcome back. In this example, we're going to look at a ladder that's sliding down a wall. And I've already taken the liberty to draw out a picture of what this looks like. It says, for example 2, a ladder 10 feet long rests against a vertical wall. So the fact that the wall is vertical is meaning or implying that it's perpendicular to the ground. I know it's not very explicit, but that's the idea here. And that way, when the ladder leans against the wall, it creates this right triangle here that we're going to make use of. Then it says if the bottom of the ladder slides away, so here's the bottom of the ladder, the part that's on the ground, slides away at 1 foot per second, how fast is the top sliding down the wall when the bottom is 6 feet from the wall? So when the bottom is 6 feet from the wall. Now it seems like there's a lot going on here, but basically the ladder is just sliding down the wall like this. So let's try to visualize what's going on with the 1 foot per second. So the 1 foot per second, we can visualize that with an arrow from the bottom of the ladder moving to the right. And oops, before I say that, and that's 1 foot per second. Now we have to have a variable here to talk about what exactly is increasing by 1 foot per second, and it's really that distance between the wall and the bottom of the ladder that's increasing by 1 foot per second. Let me use this blue. So this distance, this horizontal distance from the wall to the bottom of the ladder, we use x to represent that. And if we do, then we can represent the rate at which the ladder is sliding away from the wall as dx dt. dx dt. So you can think every second that passes, at this instant in time at least, every second that, or actually it's always 1 foot per second, no matter what time you're at. So every second that passes, x is increasing by 1 foot, so the bottom of the ladder is moving away from the wall by 1 foot. And another second passes, it's moving away from the wall another foot, and so on. Now we're going to want to know how fast the top of the top is sliding down the wall, and for that we want to have a variable to represent this vertical distance from the ground up to the top of the ladder, and we're going to use y to represent that. We're going to use y to represent that. And our goal then is to find what is dy dx, sorry, dy dt. What is the rate at which y is changing with respect to t? Now we would expect dy dt, what sign would you think we would expect dy dt to be? Positive or negative? So if you said negative, that would be correct, because if you think about the y variable represents that vertical distance, and that should be shrinking over time. As the bottom of the ladder is moving to the right, the top of the ladder is moving down, so that vertical distance, which is what y represents, should be decreasing in size or in length. And so dy dt should be negative. Every second that passes, y should be subtracting by some value. All right, so there's a picture of what is going on. Now, to get an equation that relates dx dt and dy dt in it, we're first going to need an equation that relates x and y. And thankfully, we've got this great right triangle set up here, so we can use the Pythagorean Theorem to get an equation that relates x and y. We can write x squared plus y squared equals 10 squared. And now as a next step, we're going to take the derivative of both sides with respect to t so that we introduce our rates, dx dt and dy dt. Again, that applies to all three parts, both on the left side and on the right side. And I just lost these here. Let's see. Great. Now x is changing as time is changing, right? That horizontal distance, or that horizontal distance between the wall and the bottom of the ladder is increasing as time is increasing. Y is also changing as time is increasing. So y is actually shrinking as time increases. And then 10 squared, that doesn't change at all when time changes. That's just a constant. So the derivative of 10 squared is just going to be 0. Let's go ahead and write that. That's going to be 0. Now for the other ones, though, we have to use the chain rule. The derivative of x squared with respect to time, we're going to have to use a chain rule. That'll be derivative of the outer function, leaving the inside alone, where the inside is x here, times the derivative of the inner function with respect to time, so dx dt. Same thing with the 2y, or sorry, with the y squared. Another chain rule. So this is chain rule, and this is another chain rule. I'll write rule in there. There. Now what we're looking for is dy dt. So we're looking for dy dt. So we can solve for dy dt by subtracting the 2x dx dt, and then dividing both sides by 2y. Notice the 2's cancel on each side. We could divide both sides by 2 to get rid of those. And then we have negative x over y times dx dt. Okay. So at this point we have dy dt solved for. We just need to input all these variables. We need to figure out what x is, what y is, and what dx dt is. Dx dt we already know is 1 foot per second. It says how fast is the top sliding down the wall when the bottom is 6 feet from the wall. So let's translate that. 6 feet from the wall translates to x equals 6. Right, x equals 6 feet. So the 1 foot per second, let me just write that in there, is dx dt. And then the x value is 6 feet. But we're kind of stuck here though because we don't know what y is. But that's okay, because if x is 6 feet, we can figure out what y is by using the Pythagorean theorem, by using this relationship between x and y. So here we're going to get y by using the fact that x is equal to 6 at this particular point in time, and writing up the equation that relates x and y. And when you solve this, taking a couple of steps, you should get y equals 8. So square the 6 to get 36, square the 10 to get 100, subtract the 36 over, and then square root both sides. Now you technically get plus or minus 8, but here y is representing a positive length or a distance, and so we're going to take the positive value. So now we're all set. We can plug in everything that we need, and we'll get 6 over 8 times 1, which is negative 6 over 8, which is negative 3/4 if we reduce it. And the units here, what do you think the units are going to be? If you said feet per second, then that's correct. Y is in feet because everything else is in feet, like x is in feet. T is in seconds because when we looked at dx dt, the t was in seconds. And so we have feet per second. Now the only last thing I would say is when we're answering this question, how fast is the top of the ladder sliding down the wall we already have a sense of direction. It's saying how fast is it sliding down the wall. So we might not say negative 3/4 feet per second. We can just say it's sliding down the wall at a rate of 3/4 feet per second. So I'm going to write that as a sentence. So the top of the ladder, or more or less a sentence, is sliding down the wall at a rate of 3/4 feet per second. The fact that it was negative is because the value of y is shrinking. That y distance is shrinking as time goes on. But when we're talking about the top of the ladder sliding down the wall, like that point where the ladder touches the wall, sliding down the wall, you would probably just answer someone, it's sliding down the wall at 3/4 foot per second, or feet per second. So there we have it. Let me see if there was anything I wanted to say. Nope. All right. So thanks for watching, and see you in the next video.